Hey, everybody.
There we are.
Welcome to today's webinar. We are super happy to have Mark Gamble back with us. As you know, this is a three-part series. This is the final third part. And we're going to dig a bit deeper into the code today. We are joined today by Wayne Carter, VP of Engineering at Couchbase. So we're going to have some great presentations and demonstrations for you today. If you have questions, please add those to the Q&A. We will probably address the Q&A at the end of the presentation and demonstrations. If you missed the first two webinars on Couchbase Mobile, they are in the docs section, so please check those out to learn a bit more. If you're interested and want to try Couchbase Mobile, it is included in our free tier offering. You can find a link to that in the docs section as well. And finally, I know everybody asks for a copy of the deck at the end of the presentation. That you'll find in the docs area too. So thanks so much for joining, and I will turn it over to Mark Gamble. Thanks, Mark.
Thanks, Suzanne. Thanks, everybody, for joining us today. I see Ron, Alan, Roman, Ryan, Mohammed, Gurjo. Wow, we've got a cast of many here. Thanks for joining us, everybody. Again, Mark here with Couchbase, and welcome to the third installment of our series. As Suzanne mentioned, we're going to be diving into how Couchbase Mobile enables a mobile AI app ecosystem that provides guaranteed uptime and real-time speed for AI-powered applications, because it's a comprehensive mobile database platform. And I'm especially excited to be joined today by Wayne Carter. He's the VP of Engineering at Couchbase. He's a brilliant visionary and accomplished developer. And in fact, Wayne, you built the amazing mobile demo apps that we showcased in the first two parts of this mobile series. So it's great to have you with us today.
Yeah, great to be here. I love working with Couchbase Mobile and kind of demonstrating its capabilities. So happy to be here today to kind of show what I've done in the AI space.
Nice. We've got an action-packed, exciting program today. I'm going to do less talking for a change, and we're going to have Wayne do some talking. But I'm going to start with a bit of a refresher on Couchbase Mobile, and then we'll dive straight into the example of an AI-powered mobile app at the edge by looking close at Wayne's app, Simple Intelligence. And this includes a look at code and a live demo. So be sure to buckle up and let's get going. Just to start, for those that are tuning in for the first time in our series, our mobile capabilities are a specialty, but really only part of the broader enterprise capabilities of Couchbase. And so that's where our story begins. Couchbase is a cloud-native NoSQL database that's used to power gigantic applications for our customers, such as LinkedIn and PepsiCo, Tesco, Comcast, Amadeus, United Airlines, and the list goes on. Big household names who use us to power their mission critical applications. And that's because Couchbase is so versatile and powerful. It's a combination of database capabilities, which is why we call it multi-purpose. It's an in-memory KV store, and that's for primarily speed and responsiveness. And it's combined with the distributed storage of JSON document based data for scale and resilience. And that brings a tremendous amount of developer flexibility as well. And then on top of that, we had support for vector search from cloud to edge, full text search, eventing, columnar analytics. We're container friendly. And we have, of course, mobile sync, which we'll be diving deeper into. But these are all data access patterns that customers typically would have to knit together from disparate technologies, but not with Couchbase. We combine it in one platform. And Couchbase supports relational constructs like SQL queries and ACID transactions. And these are not typically found in a document database, but this allows our customers, developers to adopt NoSQL while maintaining their existing skill sets. And you can deploy a Couchbase using Capella. This is our hosted and managed database as a service, or you can manage and deploy your own Couchbase server deployments in the cloud or on premises. And this represents Couchbase in a nutshell. And when we consider how we support mobile and edge computing architectures, That's with the Couchbase Mobile product stack. And the Couchbase Mobile product stack is made up of these three foundational components that can be combined and knit together, sort of like Legos stacked together to support any topology. But the three components here are Couchbase Server, that's what I just kind of talked about, the flagship distributed NoSQL document database. And then we have Couchbase Lite. And this is the embeddable version of Couchbase for mobile and custom embedded devices. And it also supports, just like its bigger brother, Couchbase in the cloud, it supports SQL and vector search and full text search and the like. And then in between here, notice we have Sync Gateway. This sits in between it, and that's responsible for secure data sync and routing and access control between the client and the server tiers. And just like the rest of Couchbase, you can deploy this using fully managed and hosted, that's using Capella, or self-managed, that's where you would install and manage it yourself on your own cloud or on-prem. And Couchbase Mobile, sort of cutting to the chase here, we've got a depiction of the edge architecture where we're representing a cloud database, an on-prem or near localized database near the edge, and then ultimately on device. And it can interact also in any of these tiers with AI models that happen to be living lightweight on device, at the edge, and out on the cloud. And that's because we can run, search, and sync data anywhere in all of these, and then also synchronize data between and within the layers. And that allows applications to store and process data at the point of interaction without relying on that central cloud data center. And that fundamental capability allows us to support any complex edge architecture to meet any speed, availability, or security requirements for our customers' AI-powered applications. Now, because Couchbase Mobile supports offline first vector search at the edge, let's dive in just for a moment to a very specific use case for vector search, and that's visual search. So when we consider, visual search, what do we mean? And to illustrate the concept in simple terms, let's think of how a human recognizes things visually. We'll focus on a specific item, we recognize what it is, and we respond accordingly. For example, if I were a grocery checker, I would see an item, let's say an apple or a tomato. I would recognize it. I would charge a customer the corresponding price and put the item into the bag. And the more I do this, the better I become at identifying items and their prices by simply looking at them. So imagine an app that could mimic this type of human behavior. And that's exactly what Wayne built it with simple intelligence. And we'll pop up the QR code. But this is a simplified depiction of vector search in Couchbase Lite being used for visual search. So first, the app on device would scan the item using the device camera. We showed this live in our last installment. Then it calls a local embedding model, also running on device, to embed the captured image with vectors. And next, Couchbase Lite vector search looks for the nearest neighbor matches in the database vector store. And when the nearest vector match is found, the app displays the matching item and its associated information. And as I turn it over to Wayne to dive behind how this concept works in practical application, Simple Intelligence is out on GitHub. All of the code that Wayne will be walking through here today is part of this package, including a link to the app on the App Store so that you can try all of this magic out. So with that, Wayne, I'm going to turn it over to you, and I'll stop sharing our slides.
Okay, great. So let me share my screen. Let me just having a hard time finding the button here. Oh, there it is.
Left side panel, yeah.
Yeah, found it. Okay. There we go. Okay, you should see my screen. Okay, let me get off of that. Can you still see me in my screen?
Yeah, you look
Mark?
great. Everything looks great, Wayne. Thank you.
Can someone confirm that they can see me and hear me?
Yeah, can you hear me, Wayne? You're coming through good.
Okay, perfect. Thank you. All right. So to start the what I'm walking through today, you can walk along if you would like. I've got this on my GitHub repo, so it's just Wayne Carter, and then it's under Simple Intelligence here if you want to find this README. Well, let me just start at the top. So this app, I created this to showcase the capabilities of our entire Couchbase stack, both using Couchbase Mobile to show how offline first can bring high availability and high speed to distributed environments, but also how do you connect this to Couchbase Capella, which is our cloud hosted product. And then how do you search and synchronize and use all of the different capabilities of the database around AI, vector search, full text search, integrating SQL, right? So really great to be able to integrate these different search capabilities into a SQL statement. So you can use all of the richness of SQL. And then how do you speed those up using indexing and bring those down from the cloud using Sync? And as Mark mentioned, I have a couple of links here to the App Store if you want to download the app. And then also right here at the top, if you want to try out the demo, we have some demo images that the app is loaded with a demo set of images that it's been trained on, and you can use those to try out the app. And these steps kind of walk you through that. But let's kind of get into the code. And I'm not going to jump into the IDE. I've got in this README, I've got a good amount of code blocks that we can just walk through. So we'll just do that. But at the very end, I'll kind of point you to the classes that you might use to get started at the bottom. So the code's divided up into the different kind of search capabilities, AI, vector search, SQL, full text search, and let me walk through those. But let's start with AI, since that's the thing that's most top of mind these days. So in the database class, you'll find a couple of search methods. One of them takes in just a simple image. Right, this is written in Swift, so UI image is the image class for that platform. And then it demonstrates how to search with those. So when the image comes in, it's actually doing a couple of things here. So it's looking to see, well, is this a barcode that is being scanned in, or is it an image? If it's a barcode, go towards the AI that is good at recognizing barcodes and bring those in, and then do a search using those barcodes. And if not, go down, get the embedding out of that image, and do a search using the embedding. So vector search is what that is. And then it returns an array of products. So it'd be empty if it didn't find anything, or it would find all of the products nearby. And the search functions uses AI for processing the images. So the image comes in. I'll just show you a quick demo just to kind of set the ground. So this is the back up in the demo section. I linked to a PDF here. And this is the PDF. It's just got a bunch of different images that the app's been trained on, and you can just point the app at one of them. And let me pull the app up for you. So you can see here's my app. And if I point it at the image, it just pulls it up. All right. And it also does barcodes. So if I just point this at this barcode, then you can see that it works with that also. All right. So getting back to the code. All right. So when it does AI, it's using, you can see here that it's calling to the AI class in a couple of areas here. So AI.barcode, AI.embedding. So let's dive into the AI class just a little bit to see what it's doing. So for the AI embedding one, what it's doing is it's taking in the image, it's going to convert that into a lower level image format, and then it's going to then process the image and grab the embedding from the model. The model that if you want to look at the model and how it's used, it's a lot more code than this, but if you want to just check it out in the AI class, just follow it down to this embedding class that takes the processed CG image, and you'll find all of the Apple models that I'm using for that. It's using the fingerprint embedding model, I think. I can't remember. It's been a while since I wrote that, but it's something like that, fingerprint image or fingerprint something. But it's doing, what it does is it extracts a vector out of the image. And it uses some some attention, not attention, but focus mechanisms. So things like cropping, face recognition and zooming in on an image to kind of take an image and turn it into something that's more focused. So it can actually kind of embed the focused area. And I'll show you that here in a second. On the barcode side, this is actually, I don't think it's the exact code, but it's very similar. I kind of streamlined it a little bit. But you can see here that it's using the VI image request handler and the detect barcode request from Apple to use their models that are on device, always available, always fast, right? Those things are going to return in just a few milliseconds. And they're not reliant on the internet. And it's using that model to extract the barcode. And if it finds the barcode, then it's going to return it. Otherwise, it just returns nothing. All right, and so on the image processing, which you can see here, I'm saying like, okay, processed image is grab the processed image and then pass it in. You can see here where I'm doing the processing. Really what I'm doing here is there's different focus mechanisms that I've added to the AI class that says like, what type of saliency do you want? Meaning, is it attention or is it another type of saliency? Are you looking for foreground segmentation, right? Are you looking to just snap on to what the image is kind of focused on the foreground object and then focus on that one? And let's focus on that for the search. It also has faces, so face detection. So find the faces in the image and grab those rectangles and crop to that area. And then some zooming focus components where you can like send it an image and then maybe do a couple of queries that are kind of converging on a more focused space, right? And you're zooming in to try to find something that you recognize. And these types of techniques allow you to go a lot further than just feed in a raw image. And images contain a lot of things that you're not looking for too, right? Many images do. And they're not just strictly the thing you're looking for. And so these types of focus approaches, I've demonstrated some of them. There are others, like removing color is one way to create focus, right? If you're looking for shapes or, the color doesn't really play into similarity, then, just dropping the color is a great way to create focus. But there's all kinds of ways to do that, right? Just restrict the space that you're actually trying to analyze. All right, so moving on from that, and those are all found in the AI class. All right, so now on to vector search. All right, so one of the mechanisms, right, when you send an image is to do a vector search, right? That's what's happening here, right? So it gets an embedding, and if it finds an embedding, it's able to produce one, then do a vector search using that embedding. All right, so here's the function for that. It's pretty straightforward, right? It's a SQL. So all of our technology works with SQL, right? So you're just like everything that's in SQL plus these other capabilities like full text search and vector search and many others. And in this case, what I'm using is vector search here, and I'm looking for vectors that are pretty close to the one I'm looking for, right? And you can kind of in your testing, you can decide how close you want things to be. The 0.25 was close enough for me on this one, and I only want to return just a few, so I limited it to 10. And that will get used down when we do things like KNN and some of the other things in the vector search. We use this limit in addition to the information you pass into this distance function. Okay, and then we just execute the query and get the results. So just like you would any normal query, once you've got the query set up with your parameters, and you can see that I'm doing it here. I'm passing in, where's that reference? There it is, $embedding. That's referencing a parameter that I'm passing in. So I'm just passing the vector so vector passed in here, passing the vector in as an embedding parameter into the query, and then I just execute the query, get the result, and return it. And you might do here, and if you look at my code, I actually do. I've just kind of streamlined a little bit for this case, but you see I'm just writing all the products into this products array and then returning them. But you could also add a filter there, right? You could say, since you're doing distance matching. And if you find something like really close, like maybe it's like 0.05 or something like that, you might throw out any other matches that are kind of further away, or to some amount of further away, because something very close is a much better match than, you know, even if you're looking for 10 or something like that, you might just throw them out. And you can see that kind of filtering that I'm doing in the source code if you want to check it out. All right. And then, and these product classes are just my own product classes, if that's not clear. Just a model. All right. Now getting on to search, right? And this is where barcode is done, right? So the AI has been done outside of the search function itself, right? Because I do that up in the search image function. I say, oh, is there a barcode in there? If so, call search barcode. And then I'm just going to do just a simple query for that, a simple SQL query. So just see if the barcode equals the string barcode that's passed in. And if so, just load it up into products and return it. Okay. And then full text search. Let me just kind of show you a demo of full text search really quick. It's also in this app. So if I click on the search area here, so down at the bottom you have AI, which gives you a camera, and then a search that gives you this text. If I look in here for like you know, food, or that's a category, right? Food or home or Bolt. So you also have full text search demo there. And what that does when you're using that part of the app is it's just calling into this function in the database where it's passing the string you're looking for, and it's using our full text search capabilities. So that's this match function here and this rank function here are what activates your full text search. And you can see I'm just passing there's a typo here, but oh no, there's not. I'm passing in the string as search right here. All right, going forward, and then it's just a regular query after that. You don't need to do anything other than load up the SQL, and then we'll take care of all the other details around full text search. All right. Also in the demo database class, I show how to use indexes. This is where you're going to be able to create fast searches, right? If you have a small data set, like really, really small, you know, maybe indexes don't make sense. But if you have a relatively large data set and you want to, you know, ensure that it can execute in a kind of standard speed, right? Something that's not based on the data set size, or at least not wholly dependent on the database size, and you're going to want to set up indexes. And you can see here the ones I've set up. So I want to be able to search by name so that I can sort things really fast. Sorting comes into play too when you're talking about indexes. I want to be able to search on the barcode field, so I'm creating an index on that. I want to be able to search on the embedding field for vectors, so you can see I'm setting up a vector index for that. These are just kind of value indexes, or just like normal old indexes for scalar values that you use in SQL. And then we have a few other ones. So vector indexes for vectors, and then full text index is for full text search. All right. And then getting into synchronization. So, you know, the app can run standalone if you would like, right? But in many cases, you're wanting to synchronize your data with some other system, some other backend. In our case, that would be Capella or some self-hosted Couchbase components. And that lets you change data, whether you're changing in the cloud or you're changing on device. You're able to synchronize that data when there's a network connection, right? It works offline, but when there is a network connection, you're not offline, you're online, and you can reach the cloud, then synchronize with it so that you can kind of reconcile the differences in the data set since it's been offline. And it's pretty straightforward. You just set up a replicator, setting up a basic one with a URL, and which I'll show you in a second where you get those from Capella, but it's from your Couchbase setup. And then I'm just setting up a replicator. I also want it to be authenticated. I'm just using simple basic auth on this one. Passing in my username and password from my config, and then just starting the replicator. That's all you need to do. We'll take care of the rest of it. Okay, now moving on just a little bit into the demo project, and how you kind of use it. It has a couple of setups, and I've demonstrated them here, but you can come up with many other ones, I'm sure. But what I wanted to do is imagine different ways you might want to deploy an AI model and a camera and an application in real business cases, right? So in this one, I imagined an iPad or some similar device being set up in a kind of point of sale setup. So you have a camera that's kind of that you put your objects in front of. So if you imagine it kind of like a Whole Foods, right? You walk up to the point of sale system. Normally you would type in like broccoli, organic, no packaging, you weigh it, and then you put it in your bag, right? It might take like 20 seconds or something like that. It's not too long, maybe 10 to 20 seconds. But if you imagine kind of flipping that now, and you imagine it as, well, kind of like, can you just look at what I put on the counter and just like pull it up and I'll click OK. If you found it, otherwise I'll search. So you kind of flip the mechanism, right? Where just let the device look and give you the best guesses or best match. And if it's not that, then switch to the keyboard. And that's what this one imagined, right? And you would be able to then move something that takes 10 to 20 seconds down to like kind of 2 seconds or something like that. Just put it on the counter, click OK. Because the actual lookup is going to happen, sub-second, right, down in the millisecond ranges. So that's the setup. And you can set it up kind of backward facing, in this case, like on a stand, or kind of frontward facing if it makes sense for like price lookup at the front door of a store. Right, it's not the same as buying something. You just need to know where it is. Right, so that might be a front-facing camera. I'm walking to Home Depot. Hey, I need to replace this thing. Where is it? And you just hold it up, and it says, oh, that looks like a bolt for a cabinet. It's on aisle 10. All right, so that's that first setup for kind of kiosk style setup. Then there's the phone setup. So this would be like, you can imagine consumer-facing, where you have an app that you want to be able, that the customer can scan things and get things from their phone directly. It also could be like employee facing, where you have maybe personal shoppers running around or doing work for the business or for customers that they need a mobile device that's not mounted in place. And so that's what this one is intended to demonstrate. And just a couple of examples of the demo cards, which I've already showed you. But if if I point my camera at one of these like before, all right, it's going to pull it up. Okay. All right. And then this next section goes over how to customize the app. So yeah, it's got the preloaded data that you can demonstrate from the PDF, but also you may want to add some things. Right, so you might want to actually add new images or products to the catalog that you want to demonstrate or show how to use, and that's what this section is about. So I'm going to walk through it and I'm going to actually use it. Okay, so the first thing I need to do is create a database, create an app service, and then configure the app service endpoint in Capella. And so I've already done that. And so what I did was I created a database. I just called it simple. Inside of that, I created one bucket that I called products. And that's where all my data is going to go. Let me just kill that. So let's see, switch back to it. Then I need to create my app service. I've already done that. So you can see here, I've just get back here to take it from the top down. So I've created an app service I just called it simple, which was the same. Then I created an endpoint called products. And I've configured that. And the first thing you need to configure is you need to configure your access control. So access control, and I'm just going to add this access control function. So access control is done here in this tab, access and validation. You click on your configured collection, and then you just put in the JavaScript function. In this case, what I'm saying here is I'm saying, don't allow anyone to write code. So this sync function runs every single time a mutation comes through the app service. And so what I'm saying here is I'm saying don't allow anyone to write through this service if they're not an admin. They have to have the role admin. And then only allow docs of type product. And then if it's of doc type product and it makes it through, channel that to the channel product. All right, so type is always going to be product, so it's going to channel to product. All right, that means anyone with the product channel will now be able to read the records. Okay. And the second thing you need to do is you need to set up cores. So the way I've done and the reason I need to set up cores, let me get to that in a minute. Let me set up the users first. I'll come back to cores. So now you need to create your users. I'm creating just one user called admin that has that admin role, and I'm creating another non-admin user, which I called Wayne, that has access to the product channel. Let me show you that. So I'll start with roles, because my sync function requires a role admin. So I've created the role admin. And I've also given the admin access to product if they would like to read it also. And then I've created two users. I've created the admin user and I've created the Wayne user. So the admin user has the admin role. And the Wayne user has the channel product. Okay, so I've set up my users. And then let me just look at cores. So what I'm going to do is I'm going to look at this intelligence admin tool. So it's right here in the repo under docs, so that it in this docs.index file. So this is what I'm going to show you. That's all the code for it. And it's just talking to the app service backend using REST. That's all it's doing. And so we need to set up cores to allow that, because my admin tool is now running in the GitHub domain. All right. So I need to put these into my core so I can do cross origin access. All right. So how do I do that? I go to settings. I go to advanced. I click on enable cores. This will be off by default, so turn it on. And then I set my origin to GitHub. And then I also want to be able to log in. Right, these are authenticated users, so I also need to add the login origin as the same. So I'm going to allow you to log in and read and write from GitHub. And I need to set a couple of headers. So I added those. All right. And then we can just go to the tool and use the admin to set up a product that we don't recognize already. So let's go ahead and look at that. So I've got this cat, and when I scan it, nothing happens. It's not in my system. So I can't find this cat, but I wish I could. So let's make it so I can. So this is the tool. If I come back here, it says you need to configure the sync endpoint, and it's really just the endpoint, not sync endpoint. We're using REST, not sync, and using the non-admin user. So I'm going to do that. So first I need this endpoint URL. The way I get that is I come to my endpoint. So this is my app service endpoint. I click on connect, and I just get it from here. All right, so I can just copy it. All right, but I've already done that, and I've set up my admin user. I've said I want to add a cat. Just add a couple of fields. Right, it's a cat. It's in the animal category. It's kind of pricey, and it's located at store 2. And here's the image. All right, so you can just choose an image, which I've chose this cat, and now I'm going to add it. Just got a little confirmation here saying here's the new document ID, the record ID. So it was added, and that's the ID of the record. But we don't need that. All we need is this. And now I can see the cat. Oh, let me do that again. Wasn't sure. Okay. And now just point at the cat, and there it is. And that was done. It just synced it down via the replicator that we have set up. Okay. And then just to kind of close everything down, and then we can move forward. So if you want to build the project, all you need to do is clone the repo. You will need to download the Couchbase Lite frameworks for this. So you'll need the Couchbase Lite framework and also this extension for vector search. So just grab both of them, put them in your project, open the project, then run it on your phone or tablet or build it or however you would like to do it. So it's pretty straightforward. And then if you want to explore the code, there's a lot of UI in there that I would just ignore, but I put it under a directory to kind of hide it, but all that's just UI stuff, right? The real meat is in these 4 classes. So the database has all of the database features, which I showed you, plus some additional details. The AI class provides all of the AI capabilities and some additional details that I didn't go over. The camera kind of marries those things together from the camera perspective. And then the settings is where kind of all the configuration is pulled into the app. So if you really want to know how this works, these couple of ones are the ones I would look at. All right, so let me stop sharing.
That was awesome, Wayne. Let me get back into slides, although slides can't measure up with how cool that is. Absolutely just love it. So let's see, I'm going to get back to the layout where people can see us and slides. And you guys take advantage of this awesome resource. It's a great learning thing. We at Couchbase use it at events and customer meetings. The customization is so cool that you can scan things in just minutes before you show it off. Wayne showed it live. So it's an amazing application. Wayne, thanks for showing that off. And as we wrap up, let's kind of imagine other use cases. As the app shows, visual search is great for retail scenarios, right? Where mobile devices and kiosks and cameras can streamline the shopping experience. But it can also apply to things like insurance claims, out in the middle of nowhere in a disaster zone, for example, where photos of damage can be used to assess costs and find replacement parts and recommend service providers. And visual search can also speed up things like the check-in process at airports and hotels, using passes or facial recognition. And that saves time, makes customers and passengers much more happy. And the use cases go on. Embedded smart mirrors in fashion retail locations can use images of the consumer, and the device can simulate how they might look wearing different outfits and accessories, right? So much less cumbersome than endless trips to the fitting room. And smart cities are gaining huge benefits from visual search, using sensors and cameras around town to optimize things like snow removal or streetlight usage that can save millions and millions of dollars for metropolitan areas. And cameras are a mainstay, of course, of security and surveillance systems. Tying visual search to the captured images can detect security risks and do things like help find missing persons. And defense, where drone footage can be used to identify threats from remote locations, and where the ability to work without internet becomes a huge advantage for tactical operations. These are just some of the types of use cases for visual search at the edge. And we have lots of noteworthy customers using Couchbase Mobile. Some are household names, others are small startups, but all can have these specific requirements for high scale, offline first mobile applications. And we wanted to be sure to mention that Capella offers a free tier, right? The back end that Wayne was showing, you can set up and do the exact same demo and all your customization and whatnot, leveraging our free tier, which supports app services, as well as the database as a service. So you can try out those capabilities and that same demo with zero cost, zero risk. And it's a great way to start learning Couchbase kind of see how the cloud to edge AI and data sync can work for your own mobile and IoT apps. So take advantage of it. You can sign up using the link in the resources that Suzanne has posted. And as we wrap up and get into any questions, if they are out there, you can use the Q&A panel to type those in. Just want to mention, again, I know I've said it all throughout the series, but at Couchbase, we've been doing mobile for over a decade, and we aren't going anywhere. But it's a specialty of ours and a differentiator. If you're affected by MongoDB's recent deprecation of their mobile support, Couchbase is here as a better alternative, providing that end-to-end enterprise class mobile database platform built to power these types of applications, and built for AI as well. So we've been looking forward, thanks to Wayne and his good work and all of the engineers at Couchbase. Fantastic stuff. And let's go ahead and get into any Q&A that might be out there. Any questions, folks, coming in? So Wayne, I know one that's usually in the FAQs, but what's the actual AI that you're using in this application? I know you talked about methods and whatnot. What's the actual library that you're using or package?
I'm using Vision and CoreML from Apple.
Got it.
That's a pretty rich set of models if you guys haven't used them, and they're all on your devices, and they're quite nice. Now you can bring in other ones, of course, and I've played with a few others, and I'm playing with some now. But in this demo, I wanted to keep it kind of straightforward, kind of remove the complication of getting a model that runs on these different devices, bring it down to size, and just use one that's really specialized for these mobile devices. So those are the ones I'm using, and there's a number of other ones that Apple has that are quite nice.
Great. So the one thing we didn't really get into is platform support today. What we did, of course, in the previous sessions, but Wayne's built all on iOS, but of course, all of these capabilities that Wayne demonstrated are available on all of our supported platforms. So wanted to you can do this in Android, for example, and so wanted to make a mention of that. Take advantage of the, again, free tier, the fact that you can try out Couchbase Mobile for free, and that this great resource that Wayne built is out there to serve as the model and reference implementation of some of these concepts. So with that, I think we're ready to wrap up. Wayne, again, thanks so much for being here. I think that was just amazing. Seeing some feedback coming through the chat. Everybody really enjoyed your presentation. Fantastic stuff. And look forward to our next series starting early next year. Happy holidays to everyone. And thanks for joining us. And I'll turn it back over to Suzanne to wrap us up.
Yeah, nothing more to say there. Thanks so much, Mark and Wayne. Thanks everybody for your time and attention, and hopefully we will see you again very soon. Take care.